so here we've got the notes for section 3, which deals with the applications of normal distributions. So in working with normal distributions that are non-standard, which means that the average isn't necessarily 0 and or the standard deviation is not necessarily 1, we use the following formula to transform an x-score to a z-score, and then proceed with the same methods we did before. So the z-score, to turn any number into a z-score, is you take whatever value you're given, you subtract the average, and you divide by the standard deviation. So what that means, always round to 2 because your table's set up to be 2. So the social organization Tall Clubs International has a requirement that women must be at least 70 inches tall. Given that women have a normally distributed heights with a mean of 63.8 inches and a standard deviation of 2.6, find the percent of women who satisfy that height requirement. So I need to convert my x value, which is 70. Here's my average and my standard deviation. And I need to convert those into a z-score. So the z-score is equal to the value I'm looking at minus the average divided by the standard deviation. I'm going to round that to 2 decimal places. So that's going to be 70 minus 63.8, which is 6.2. And then we divide that by 2.6. So that rounded to 2 places is 2.38 is my z-score. So they have to be taller than that. So the percent of women, so 2.38 is, that's a positive z-score. So here's my z-score table again. 2.3 is right here. I'm going to go over to 8. You guys can't see the headings, but it's right here, 0.9913. So now remember, that's set up to be a less than. So the likelihood that is less than that is 0.9, whoops, forgot where it was, 0.9913. So that probability is that the likelihood that the person is less than that corresponding z-score. So 1 minus 0.9913 is 0.0087. So less than 1% of women satisfy the criteria, if that is the actual criteria. Okay. So flip it over here. It says British Airways and many other airlines have a requirement that a member of the cabin crew must have a height between 62 and 73 inches, given that men have distributed heights. So there's my average, there's my standard deviation, find the percent of men who satisfy the height requirement. So I have to find 2 z-scores, one for the low end, 62 inches, one for the high end. So for the z-score low, that's the value, minus the average, divided by the standard deviation. I have to do the same thing for the high end. So 73 minus 69.5 divided by 2.4. So I'm going to do this all in one step. So 62 minus 69.5 divided by 2.4. So this is the z-score of negative 3.13, rounded to 2 places. 73 minus 69.5 divided by 2.4, this comes out to be 1.46. And then I need to convert those into percentages. So the likelihood that I am less than negative 3.13, and the likelihood that I'm less than 1.46. And then I'm going to find the difference between these two values. So the first one's a negative z, well, we'll do the positive one since that's one that's closer. So 1.46, so 1.4, 0, 1, 2, 3, 4, 5, 6, 0.9279. And then the other side, mine's got 2 separate pieces of paper, negative 313, negative 3.1012.0, whoops, 0.0009. Then I need to find the difference between the two. So 0.9279 minus 0.0009 is 0.927. So 92.7% of men satisfy those requirements, lie between 5'2" and 6'1". Okay, example 3. One common criteria is design that accommodates 95% of the population. So what aircraft ceiling height will allow 95% of men to stand without bumping their heads? So this problem is working in reverse. I know I'm going to look up a z-score, and I'm going to calculate the x value. So remember, 95 percentile, I need the z-score that has 95 less than it. And from the previous section, that was a special case. See if I can find it. That was 1.645. So the z-score that corresponds to the 95th percentile is 1.645. So the equation is the z-score is equal to the specific value minus the average, so 69.5, divided by the standard deviation, 2.4. So to solve this, I got to get rid of the fraction first. So every value is multiplied by 2.4. So 1.645 times 2.4. That's 3.948 is equal to x minus, I feel like I'm doing something wrong here. I guess this is going to be way too big. Yeah, because if I add plus 69.5 plus 69.5, so x is equal to, sorry, I got myself confused. I thought I was going to have to multiply those numbers. That was going to be way too big. So that number plus 69.5, so 73.448 inches. So 95% of men are less than that height, 73 inches, which is 12 times 6. So 6 feet tall is 72 inches. So that's 6 feet, 1.5-ish inches. So almost all men, 95% of men, are less than that height. All right, so example 4, some educators argue that all students are served better if they are separated into groups according to their abilities. So we're going to separate them by IQ scores, bottom 30%, middle 40%, that should be a comma, not an M. I'm a third score with groups in the top. So what I'm going to talk about here is, so I have some value down here. So I'm dividing my curve into 3 sections. This area is 30%, this middle section is 40%, and this top section is 30%, which means this value right here is 0.3 to the left. Up here, there's 0.7 to the left, the 30 and the 40. So I need to find z-scores that correspond to 0.3 probabilities and 0.7, and then use that because it gives me the average and standard deviation to calculate the actual IQ scores. So I'm using my table backwards. I'm looking up 0.3 in the table and trying to find a z-score. Now 0.3 is less than 0.5, so it's going to be on the negative side. So 0.3, let's see here, there's 0.3, so that one's over by 15, that one's under by 19, so we'll use that one. So that's negative 0.53. So this is a z-score of negative 0.53. And for 0.7, that's more than 50%. So I need my positive side. So 0.7, 0.7, that one's over by 19. If you notice, it's actually the positive of the one I just found, 0.53. That's because they're mirrors. They add up to 1. So they're the same distance from the center. This is 0.2 below, that's 0.2 above, so they're the same values. So for the less than, my z-score is equal to what value minus the average divided by the standard deviation. Over here, z-score is equal to what value minus the average divided by the standard deviation. I'm going to do this all at once in my calculator. I'm not going to write down the intermediate steps. So negative 0.53 times 15 to get the 15 out of the bottom. And then I'm going to add the 100 across. So this is 92.05. So 30% of the population falls below that IQ score. This one, 0.53 times 15 plus 100. So this is 107.95. Now if you notice, they're both 7.95 away from the center, which is 0. So since they're the same distance left to right, the IQ scores or the same distance left to right. If I add them up and divide by 2, I should get the midpoint, which should be exactly 100. So these are the IQ scores that would break your 3 groups up. So the lower group would have anyone less than 92, the middle group would be between 92 and 108, and the upper group would be anything more than 108, which brings us to the end of the section.